Okay, number 6. I'm gonna tell you, and it says it on the solution guide as a PDF online, that you can skip it for now. We will do it second semester. It involves some calculator tricks that we have not learned yet. So I'm just gonna do A and B. So it says at first. So notice they give me V of t. And it's measured in units per second on the interval from 0 to 2 pi. And it asks me, when does the particle change direction? So you should know from before that x is position, right? So that's the direction that it's going, or where it is, right? And the derivative of x is v. And usually I find mins and maxes of x, which would be where it's changing direction, by looking at when the velocity is 0. So what I'm going to do is just graph this guy right here and then figure out where it hits the x-axis, where it's equal to 0. So what I did was I plugged that v of t in for my y1, and then I plugged my y2 in equal to 0. And I simply calculated the intersection of the two. So I'm basically solving for 0 equal to negative 3 plus 5 cosine t. And that gives me the answer. I can't pull up a calculator on this app, but it's all good. So I get 0.927, and the other one I get, need to make sure you do both of them. You got to look in this whole interval from 0 to 2 pi. Let's start with a zoom trig. 2x equals 5.355. And that's it for part A. So the next one says, and this is where we get into integrals. Particle is, position is x of t, and x of 0 is 2, then what is x of 4? So if you were to think about it, the integral of v of t is x of t, right? And then what I want to do is this 2 becomes my starting point. So when I integrate this guy right here, which I can do on my I can do without using my calculator, if I do the definite integral from 0 to 4, then that's going to be the total distance traveled from 0 to 4 by this function over that period of time. So if I do the integral from 0 to 4 of v of t, which is minus 3 cosine 5t, and then that's the distance traveled. I didn't type that right, hold on. That's what it's supposed to say. Minus 3 plus 5 cosine t. If I add that starting point, then what that is going to give me is the position that it's at after that amount of time. So I can write x of t is equal to that. So I'm going to integrate this. I can do this without a calculator. So I get 2 plus, gives me, I'm going to do brackets, negative 3t plus 5, the integral of cosine is sine t. And I do know that it stays positive because the derivative of sine is positive cosine, from x equal to, line, x equal to x, t equal to 0 to t equal to 4. So I'm just going to plug into my calculator this with 4 plugged into it, minus this with 0 plugged into it, which might be 0, I think it is, yeah. And then I'm going to hit plus 2 at the end. When I do that, that gives me negative 13.784. And that's it for that one, because you do not have to do C.